Hello everybody, I have here a problem about intensity, sound intensity level. So this is chapter 16, problem 36, end of chapter, problem number 36. Alright, so this problem says during takeoff, the sound intensity level of a jet engine is 140 decibels at a distance of 30 meters. What is the sound intensity level at a distance of 1 kilometer? So the problem is talking about sound intensity level, and it's talking about that the sound intensity level is going to change with distance. So you have to recall, find in your formula sheet an equation that deals with sound intensity level and distance. Well, the equation that you can find for intensity level is 10 decibels log base 10 of the sound intensity divided by I naught, which is called the threshold intensity. So what we're looking for is to find a relationship between the intensity level and the distance from the source of sound. So where in this equation is there a dependence on distance? So the only variable that could depend on distance on the right-hand side of the equation is the intensity. The threshold intensity is a fixed number, 10 to the minus 12 watts per square meter for humans, so that's not going to depend on the distance, it's just a constant. So the intensity must be the variable that depends on distance. So at a distance of 30 meters, we're going to call that R1, the intensity of the sound produced by this jet engine has a value of the intensity, I, and with that value, we're going to get an intensity level value of beta 1. So beta 1, according to the statement, is 140 decibels and at a distance of 30 meters. So for beta 2, which we're going to call the intensity level at the new distance of 1,000 meters or 1 kilometer, we're going to have, if we use the same equation, beta 2 is 10 decibels log base 10 of the intensity at this new distance, that I'm going to call R2, divided by I naught. So the problem is asking us to find how much is beta 2. The reference intensity or the threshold intensity is 10 to the minus 12, as I said before. And so we need to find what is the intensity. How does the intensity of sound depend on distance? So the equation that you have in your formula sheet for the intensity as a function of distance is the power, P, of the source divided by 4 pi r squared. Remember that this was discussed in a previous video. This is the equation that applies for the intensity of a point source emitting waves with a power P. So if a point source is emitting waves, any kind of wave, with a power of watts or joules per second, or number of watts, P, then the distance as you move away from the source, the intensity of that sound is going to decrease as the square of the distance. Again, this is valid for a point source, which in this case, this is a valid approximation because the size of a jet engine is much smaller than the distances involved in this problem, 30 meters, 1 kilometer. So definitely the jet engine can be considered a point source. So having an equation for the intensity as a function of distance, we can plug in the threshold intensity in the equation for beta 1. We can plug in the intensity or formula evaluated at the distance R1, and beta 1 is 140. So from that equation, you can see that the only unknown would, after doing these replacements, the only unknown would be the power of the jet engine. So we could solve for that power. So the equation says 140 decibels equals 10 decibels log base 10 of power divided by 4 pi r squared divided by 10 to the minus 12. We can divide by 10 on both sides, and the equation says log base 10 of power divided by 4 pi r squared times 10 to the 12 meters square per watt. Notice that this is not important, but I just put the denominator of that fraction, I put it as a numerator by flipping the sign of the coefficient. So that log base 10 of that quantity equals 14. And if you recall from the basic properties of logarithms from your math classes, log base 10 of x, if it is equal to y, it means that x is 10 to the y. So if the log base 10 of p over 4 pi r squared times 10 to the 12 is 14, that means that P over 4 pi r squared times 10 to the 12 is equal to 10 to the 14. All right, so one more step to solve for the power, divide by 10 to the 12 on both sides of the equation, and we get that the power is going to be 100, that's 10 to the 2 on the right hand side, times 4 pi r squared, and we're evaluating this at r1 equals 30 meters, so that gives us an amount of power equal to 1.131 times 10 to the 6 watts. This is the power at which the jet engine is emitting the sound waves. So again, let's recall that what we're looking for is the intensity level at a distance of 1,000 meters. So that's what we call beta 2. So the idea would be to replace in that equation for the intensity at this new distance of 1,000 meters, and that will give us the value of beta 2. So how do we get the intensity at a new distance? So the equation for intensity, we have it right there. So we just have to plug in for power 1.131 times 10 to the 6, and the new distance is 1,000 meters in the denominator, 1,000 square, and plugging in those numbers, that will give us the intensity at the distance of 1 kilometer away from the jet engine. So those numbers, if you plug them in your calculator, you get 0.09 watts per square meter, which you can plug back in there. And put in all these numbers in your calculator, you get 10 times the log base 10 of 0.09 divided by 10 to the minus 12, you get 109.5 decibels. So the intensity level of the jet engine drops from 140 decibels to 109.5 decibels. All right, that's it for this problem. See you in the next one.